This is Bryce, KB1LQC, giving a quick update about the progress on Faraday this week. Here I'm showing you Proxy and Telemetry running to actually control Faraday. You can see the one of the lights on the Faraday is turning on and off with my commands. It's actually blinking several times. These are all sent through post requests through Proxy. So here's a close-up view. In the bottom left corner, you'll see a light turn on in about a second right there. And that's me sending a post command to tell the light to turn on and off. You can see the blinking light above the GPS is just the GPS fix. It indicates that there's a fix with the satellites. Here's just a view looking at the telemetry aspect. I'm just querying for telemetry last heard in the previous 5 minutes. Since this is the only station on, I'm only receiving my own telemetry, but we'll go into that in a minute or two. But yeah, you can see it's very straightforward and easy, and all the parsed telemetry is in JSON format, which makes it extremely pragmatic to be able to use. So these are building blocks. Here's the basic setup of how the proxy and applications work in Faraday. So come back here later in this video, just come back here if you need to see what I'm talking about and where its place is in the core applications. So here's me just opening up the proxy and telemetry applications. You need to run both of them, first proxy, then telemetry, because telemetry uses proxy over the network interface to actually obtain data. That'll be streamlined in the future. But here is actually looking at just the proxy running, and I can query for base 64, and I'm popping data off a queue. So once you pop it off, it's gone, which is why I can only run proxy right now for this particular application. At least for one, each port has its own queue, which we'll cover later. But very straightforward. Everything, again, is over the network interface. So it's very easy to program for and to actually write applications. Here's the stations application. Well, this is in telemetry. And what this is doing is when you visit this URL, it simply looks through the database to see what stations have I heard in the last 5 minutes, which is what you saw first. Here is in the last 10,000 seconds or 100,000 seconds, and here's the last 90 seconds. So you can see what stations would pragmatically say, hey, who have I heard in the last couple minutes? Or you can actually search date ranges or search for stations. So if I search for a station that I haven't actually received before, you'll get an HTTP 204 response, which is a no content response. So you can actually, again, pragmatically write applications that can deal with that when they, query for the data. So this is just simply looking through the SQLite database. So by being able to use ISO 8601 formatted time, it's pretty easy to remember how you actually search for a date range. So we can pragmatically look at date ranges, provide user interfaces that use jQuery or something to actually easily provide some interface to search times or get all data from a certain range or an activity. If you say you had a balloon launch, hey, I flew at this time, I was actually flying. So these are building blocks of actually accomplishing stuff with Faraday. So here's actually moving on to just the telemetry application itself. The root URL, just / or nothing, will actually respond with all data heard in the last 5 minutes from the database. So you get a JSON response, and that's, again, pragmatic to program with. It's really convenient with Chrome to just be able to see it, which is what I'm doing here. But we can pragmatically go through and get this data, plot it, things like that. So that's what the user interface does, which is something we'll be building up next. We've already built a basic one, but these videos are showing the refined versions. And again, with telemetry, you get a HTTP 204 response if there's no data or you search for the bad call sign. You actually also will get a response that's helpful if you search for a call sign but didn't include a node ID. It will actually give you a hey, you're missing the node ID response in JSON format. So here's the last 90 seconds of data, and then again a time range with ISO 8601 formatted time strings. So this is me. That was me just looking at the last second. We've also actually put up the schematics, so you can see those on GitHub as well. And I won't walk through them here in too depth, but you can see the RF sections and how we've started to set up the entire Rev B board that actually you saw earlier, and all the files are up. So here's the circuit board. It's a 4-layer board, and this circuit board layout is actually already up as well on GitHub. And the inner 2 layers are power and ground, and the outer 2 layers are signal and basically signals and components. So you can go and play around with those now too. So board's very complex. You can actually, for what it is, it's actually you have quite a bit of thought into routing locations and mouse bytes for manufacturing. So I'm sure we'll do a lot more blog posts and info videos about the actual hardware design.